So when I ask about question 1, where does the graph have the largest position? If it's on one of the letters, give me the letter. Otherwise, tell me it's like between 2 letters. Okay, a lot of people are thinking where I wrote A should be P. Awesome. Okay, number 2, where does the graph have the largest velocity? So someone is saying between B and C, at C, we've got some E's. A lot of graphs, a lot of options here. Okay, so I'm just going to copy some of these down. B to C, E. Someone else is saying A. We might have to come back to this one. Okay, what about 3? Where is the largest speed? Same as number 2. We're having a lot more C's in this case, though. Okay. So, but we have some variation in responses. So I think position, everyone seemed to agree. But the velocity and speed is not necessarily so comfortable for the whole class, it looks like. So we have definitely some things to talk about. What would help? How did you think about this? What helped you understand where could I get velocity or speed from this graph? What were you thinking of?
The position to the time, like the more it moves up or down, it's the faster or slower it's going, depending on how the slope of the point.
Okay, yeah, so slope we can think of as delta. I'm going to say delta output over delta input. So in this case, it would be delta position over change in time, delta time. Those are weird ways to write that. And so we think about slope. So if I were to draw like a slope of a tangent line, specifically, right? Here's a couple of tangents. We want to know where the steepest slope is. Does that make sense? Is that kind of what we're thinking? Steepest slope? So it's where we're going to have the most vertical change with the same amount of horizontal change. So somewhere in this stretch, like if we have just a tiny bit of horizontal change, it looks like we have a fairly decent amount of vertical change. Whereas around, what was that, E? If I do the same amount of input change, the amount of output change is pretty tiny. So, okay, is the slope at C positive or negative? Is the slope at C positive or negative? Okay, good. But in terms of magnitude, and by magnitude, I mean like strip away the positive or negative, take the absolute value. In terms of magnitude, does it look like the largest slope in terms of magnitude? Okay, so this is the negative, but the largest slope if we look at magnitude. All right, so where's the largest magnitude with a positive slope? Largest magnitude with a positive slope looks like that might be at E. Okay, so do we want to change our answers? So let's try type in the chat window, type 2 and then the letter, and type 3 and then the letter if you want to change your answers and you have a better sense of how to answer those questions. So like type 2 and then the letter for where the largest velocity is, and then type 3 and the letter for where the largest slope, sorry, speed, largest speed is. And what questions do you have on those results? Do you agree? Do you have questions? Does that feel better? And what do you know now that you didn't know at the beginning? Think about that. You don't have to say that in the chat window, but think if you can at least think it to yourself, maybe write it in your notes. What do you know now that gives you the confidence to answer this question that you didn't know when we started today? And if anyone wants to share, that'd be great.
I'll share.
Yeah.
I understand kind of like what the questions are asking more, especially for number two, because I was a little confused on that. I didn't know if the largest velocity had to be positive or negative, but now I do.
Cool. So you got some definition, and I should probably just go ahead and say convention. You had a chance for me to explain, well, this is how mathematicians are going to think about it. So that helps. So vocabulary, knowing the vocabulary in the field in which you're working is definitely helpful, knowing the jargon. Okay, does anyone want to share a story they wrote?
Sorry. I wrote my story. I don't know if it's very good, but I can share it.
That's okay, we would love to hear it.
I said a ball is like fell from a third floor and hits a tree, bounces up a little and falls back down.
So your position is the height off the ground?
My position is the height off the third floor at the start, and the ball falls, hits a tree, bounces up, and then hits the ground.
Does it hit the tree at D?
Yeah, it
Okay.
should, yeah.
Yeah, well, I mean, it doesn't matter. It's just kind of curious. So that's another thing you can do with your stories to help make it a little more accurate by giving letters like that. Yeah, thanks for sharing. Alex, let's hear yours. You might be muted. I don't know.
Am I good now?
Yep, we can hear you now.
Okay. I said my story was a dog playing fetch with its owner as it sprints off as the ball's thrown, and then it kind of at the first step has to come to a quick stop, grab the ball, and then it runs back and stops and starts circling around the owner.
Okay, so can you use the letters in the graph to kind of give us like when did the dog stop, when did the dog start circling?
Yeah, so from A to C about is it sprinting after the ball, and then about at D it's picking up the ball, and then it's speeding back up at E towards the owner, and then as it gets to like about H, it's gotten back to the owner and starts circling.
Okay. We've got another story in the chat window as well. So Alex, back to you though. How do you know what parts of the graph tell you when the dog is stopped? And anyone can answer this actually. So if you think about Alex's story, what parts of the graph tell us when the dog is not moving? And you can answer too, Alex, it's okay. Yeah, how do you know when the dog isn't moving?
At about K when it's coming down to 0.
Okay, so at K, the position is 0. So I would say that the position is 0. To me, that says the dog is back to the starting point. Notice in the chat window, we've got a lot of people talking about slope. So the slope might be 0 around K too. So yeah, that looks great. But there should be at least 2 other times when the dog is not moving. Let me clean this picture up here a little bit. When is the dog not moving? And people are talking about slope. So at these 2 places, the slope is 0. And great, I lost all my A through F, so that was not very smart of me. So those would be places, and slope's probably 0 here too. Those would be places where the dog is not moving. So do you see how we can use slope to give us information about velocity and speed? Okay. Any other questions, comments, stories that you're dying to share on this? And do you feel like you have a slightly better understanding about what we mean when we're talking about velocity, speed, and how to tie derivatives to real life? So we'll do a few more practice stories throughout the semester so you can get better at thinking about how to interpret the graph. Somebody said there was a sledding story. So with this at this point here at the bottom, I don't remember what letter that was. Maybe that was E. It wasn't, but I'm going to call it E now. Where is the jump? So if we're talking about a sled going down a hill, goes off a jump and then flattens off, what's the velocity of the slope at E and F? Well, sorry, the velocity of the sled. So this would be that the sled would actually have to be stopped at those points, yeah? So think about the graph. Is the slope 0 at E and F? And if the slope is 0, that means the rate of change is 0. That means the velocity is 0. That means the sled would have to be stopped at E and F. So maybe like the sled story might need a little bit of work. Maybe you go down the hill and you stop. Actually, like the bottom of the hill could be somewhere like in this stretch, and then you start going uphill and you come to a stop. That might work. But the sled would have to be stopped at E and F. Whatever story you have your object would have to be not moving at A, E, F, and K. Any questions on that? So these stories aren't trivial. It's not just like tell any story. You have to think about them a little bit.